In this video, we're going to be talking about the derivatives of inverse trigonometries. Now, the derivative of arcsine of u will be u prime divided by the square root of 1 minus u squared. The derivative of arccosine of u will be just the negative of derivative of arcsine of u. The derivative of arctangent of u be u prime over 1 plus u squared. The derivative of arccotangent of u is the same as arctangent of u, but just put it negative. The derivative of arcsecant of u be u prime over the absolute value of u multiplied by the square root of u squared minus 1. Same as true with the derivative of arccosecant of u be the negative derivative of arcsec of u. Moving on to the examples, let's start first with the derivatives of arcsines of u. The formula for this once again will be sine raised to the power of negative 1 of u be u prime divided by the square root of 1 minus u squared. Now in this case, let u here be x and u prime be the derivative of x, which is 1. Plug this into the formula and you will get 1 over the square root of 1 minus u squared, which is x squared. For derivative of arcsine of x squared, let x squared be u and u prime be the derivative of x squared, which will be 2x. So this once again, you will get 2x over the square root of 1 minus u squared, which is x squared raised to the power of 2. Let's move on with the derivatives of arccosine. The formula for this once again will be arccosine of u be the negative u prime over the square root of 1 minus u squared. Now in this problem, let u here be 2x and u prime be the derivative of 2x, which is 2. Solve that and you will get negative 2 over the square root of 1 minus u squared, which is 2x raised to the power of 2. The derivative of arccosine of 4x squared, let u here be 4x squared and u prime be 8x, as that is the derivative of 4x squared. So this once again based on the formula, and you will get 8x squared over the square root of 1 minus 4x squared raised to the power of 2. Let's continue on with the derivatives of arctangent of u. The formula of this will be arctangent of u is equal to u prime over 1 plus u squared. Now, for this problem, arctangent of e raised to the power of x, let u here be e raised to the power of x, and the derivative of e raised to the power of x is the same. Still e raised to the power of x. It does not affect it. Now, solve this according to the formula. You will get e raised to the power of x over 1 plus u squared, which will be e raised to the power of x squared. Now, arctangent of sine of x. Let u here be sine of x and u prime be. Now, the derivative of sine of x is cosine of x. I will be explaining in my future videos about trigonometric derivatives. Now, solve this based on the formula and you will get cosine of x over 1 plus u squared, which is sine squared x. Let's continue on with the derivatives of arccotangent. The formula for this again will be arccotangent of u be negative u prime over 1 plus u squared. Now, let u here be 3x squared plus 4x. And u prime here will be the derivative of 3x squared plus 4x is 6x plus 4. Now plug this in on the formula and you will get 6x plus 4 over 1 plus u squared, which will be 3x squared plus 4x raised to the power of 2. The derivative of arccotangent of cosine of x. Let u here be cosine of x, and the derivative of cosine of x is negative sine of x. Now I've made the mistake, this should be negative. Now plug this in again the formula and you will get negative of negative sine of x over 1 plus u squared, which is cosine squared x. Simplify this even further, you will get positive sine of x over 1 plus cosine of x. Let's continue with the derivatives of arcsecant. The formula for this will be arcsecant of u be u prime over the absolute value of u multiplied by the square root of u squared minus 1. Let's start with this. Let u here be 2x squared and derivative of 2x squared be 4. Plug this according to the formula and you will get 4x over the absolute value of 2x squared multiplied by the square root of u squared, which is 2x squared raised to the power of 2 minus 1. For this example, let tan x be u, and the derivative of tangent of x is secant squared x. Let's solve this according to the formula. Once again, you will get secant squared x over the absolute value of tangent of x multiplied by square root of tangent of x raised to the power of 2 minus 1. Let's continue with the derivatives of arccosecant of u. Formula for this will be arccosecant of u be negative u prime divided by the absolute value of u multiplied by the square root of u squared minus 1. Let's start with this. Let u here be cotangent of x. Now the derivative of cotangent of x is negative cosecant squared of x. Plug this into the formula, you will get negative of negative cosecant squared x over absolute value of cotangent of x multiplied by cotangent squared x minus 1. You can cancel this to each other out because it's two negatives and you will get a positive cosecant squared x. For this example, let u here be cosine of x plus 2x. Derivative of cosine of x is negative sine of x and the derivative of 2x will be 2. Plug this again to the formula. We'll get negative multiplied by negative sine of x plus 2 over the absolute value of cosine of x plus 2x multiplied by the square root of cosine of x plus 2x raised to the power of 2 minus 1. You can simplify this. because the negatives are both negative, you will get positive sine of x minus 2.